Inside of the axon bulb, you can see the vesicles and the ATP, which is produced in the mitochondria. And right here are the neurotransmitters right above the synaptic cleft, and all of that makes up the neurojunction. And over here, this is the T tubercle, and inside here there are the Ca2 ions, and that makes up the sarcoplasmic reticulum. And right here is the myosin, which is down here and under here also, and the actin right here, and then the tropomyosin right here, and then the troponin right there. An impulse travels down the motor neuron axon. The motor neuron releases the neurotransmitter acetylcholine. ACH binds to the ACH receptors in the muscle fiber membrane. The sarcolemma is stimulated and impulse travels over the surface of the microfiber and deep into the fiber through the transverse tubercles. The impulse reaches the sarcoplasmic reticulum and the calcium channels open. Calcium ions diffuse from the sarcoplasmic reticulum
into the cytosol and bind to troponin molecules. Tropomyosin molecules move and expose the specific sites on actin where myosin heads can bind. This allows the muscle contraction cycle to occur. Myosin heads bind to actin, forming cross bridges connecting myosin to actin. ADP and P released from myosin, cross bridge pulls thin and thick filaments together as a power stroke. The myosin head contains an enzyme ATP, which causes the breakdown of ATP to ADP and phosphate. This reaction provides energy that straightens the myosin head into a cocked position. During the cross bridge, this is what happens, and actin helps the position stay and be bind. Right after, another ATP binding to the myosin breaks the cross bridge, releasing the myosin head from the actin, but not breaking down the ATP. The ATP then causes the breakdown of ATP to ADP and phosphate, putting the myosin head in a cocked position again. This is repeating the cycle of the contraction over and over again. After you die, your muscles go into that last contraction, go into the cocked position, and stays there in the process of rigor mortis.
Rigor mortis is the medical term that is used to describe the hardening of body muscles after death. It's the result of the body's loss of ATP, which again is a substance that gives energy to the muscles. Rigor mortis is a valuable tool in any death investigation since it can narrow down the time frame of death. In 0 to 8 hours, the body starts to stiffen, but it is still movable. In 8 to 12 hours, muscles become completely stiff. 12 to 24 hours, muscles stay stiff, and at 24 to 36 hours, stiffness dissipates and muscles become flexible again. Examples of what accelerate rigor mortis is exercising prior to death, hot environmental temperatures, and high body temperature or fever. Examples that decrease the rate of rigor mortis is hypothermia, pneumonia, and nervous system diseases.
This concludes contraction, relaxation, and rigor mortis of the muscles.